In this video, we're going to be using the TemStaPro model on Neurosnap to predict the thermostability of proteins at various different temperatures. So for the sake of this tutorial, what we're actually going to do is we're going to do something a little bit different, and we're going to go to a protein MPNN run for beta-lactamase that we did in a previous demonstration. So protein MPNN, for those of you who might not know, is an inverse folding model, and the cool thing about inverse folding models is they can essentially predict a number of different alternative sequences for a given input structure. If you aren't familiar with this concept or want to learn more about it, I would highly suggest checking out that video. But long story short, what we're going to do is we're actually going to export this table from this run that we already did in that tutorial. And normally what you do is you just download this CSV over here, and we're going to actually feed that as an input into TemStaPro. So TemStaPro is a really cool tool, and what we're going to do is we're just going to upload that CSV from the protein MPNN run. And now what we need to do is we need to specify the column for the title. And let me just double check that. Okay, perfect, it's rank. And then what we're going to do is we're going to specify the title of the column for the sequences. We hit submit. We have all the proteins loaded. So these are all different variant sequences of beta-lactamase that were generated by protein MPNN. And next what we're going to do is we're going to hit finish and just run the job and let Neurosnap handle all the rest. For those of you who don't know, Neurosnap is an online platform where you can access a bunch of different bioinformatic tools and models, and essentially all you have to do is select the tool you would like, configure it to your liking, and upload whatever files or data is necessary, and then after that it'll run on our servers and we'll be right back with the results once the job is complete. So we are now back with the results, and as we can see, this run took about 2 minutes, so pretty good time overall, and we have a number of different visualizations that were produced from TemStaPro. So first off, let's just take a look at the first table, and let's take a look at every single column and explain what they actually mean. The first column is going to be the names of the proteins that were supplied. Because the names we supplied were just numbers, they ended up getting this suffix with the many zeros in the period. We can safely ignore that. This won't have any impact on our results. And moving on, the next column is actually going to be the length of the protein in terms of the number of amino acids. After that, we have different columns for the average predicted thermostability score for 40 degrees, 45 degrees, 50 degrees, 55 degrees Celsius, and 60 degrees and 65 degrees Celsius. Now, what does this average thermostability score mean? So if we load the first protein, which should already be loaded by default anyways, what we can see over here is that TemStaPro actually predicts the thermostability of every single amino acid within your protein individually. What we do to get a better representation of the entire molecule is we will actually average this out for every single different temperature, because TemStaPro will predict different thermostability probabilities for different temperatures, and values generally range between 0 and 1, where 0 would indicate a low likelihood of stability at that temperature, and 1 would indicate a very high likelihood of stability at that temperature. So you can basically consider them as like probabilities. So for example, for this particular row over here, you can see that for position 11 at 65 degrees Celsius, TemStaPro is almost certain that this position is relatively unstable. Now, naturally, you do want to take into consideration the entire structure, which is why we actually average things out. And if we want to go ahead and load like another one of these sequences, like this one over here that has overall greater thermostability values predicted, you can actually head over here to this last plot over here. It's a box plot. The first little area is essentially just there to show you the distribution of different thermostability scores that are predicted by the model and how that looks like. And these box plots essentially correspond to those as well. So we can see that for this particular protein, the overall distribution of different amino acids is kind of leaning towards more thermostable, and this is more or less the trend all the way up until around here. The median is still positive, so this might be one of the more thermostable variants out of the entire batch. And this is essentially how you could go about in terms of like optimizing thermostability out of a data set of potential variants that you are investigating. So hopefully this video made sense, and if you have any questions, feel free to leave them in the comments below, and we'll be more than happy to get back to you as soon as possible. Additionally, if you have any suggestions for future videos or future content, then leave a comment, and we'll be more than happy to get to that as well.